Good afternoon to all of you. Myself Suresh Tawar. I am working as assistant professor in Department of IT, Saint Martin Engineering College, Secunderabad. Today I would like to express about Bimore string searching algorithm. What is the use of that Bimore algorithm? Oh, what is the importance of that Bimore algorithm? What are the fundamentals of Bimore algorithm? Why the Bimore algorithm came? What is the use of that one? Already so several algorithms are there, but even though why we're bringing that one Bimore algorithm here? What is the agenda for that one? See, for I'm moving to this one, first I'm going to say about the pattern matching. Pattern matching in this it will come. It's going to play a major role here, where it's a string matching. We want to first you can take the pattern. What do you mean by pattern matching here? Pattern matching is nothing but mechanism of checking the particular patterns. We are going to determining the pattern within the text. Whichever text they are given within that we are going to check. For example, I want to show here, check check it once. When we are going to search the particular things, we want to check. Okay, na? Searching. You will give the one pattern. In that pattern, we are going to search in string. Okay, na? For example, see here. For example, see here. I want to show you pattern matching. Okay, na? Pattern matching, suppose they will give pattern A, suppose they will give pattern A, B, C, D, E, D. This like you will give the pattern, you will give the text this like. Okay, na? Again you will give the pattern. This like pattern we can use, we can check the each character. How are we going to check the each character? You can see, for example, I will get this A, C, D. This is a pattern, this is a text. We are going to compare each character. Each position we are going to check, we are going to find out the matching character here. See, for example, I want to check means what? I want to check position of here, this one. Index of 0th, we are going to check. We should compare that both. Okay, if matching means you can move your position to next. Again, you can check the characters. This is we can call pattern matching. When pattern going to be matched, both the pattern and text should be same. Then we can call, that is called pattern matching. Can call. Okay, now, again we move to the next slide. See this next slide. Some fundamentals are there. Okay, fundamentals. How are we going to compare that one? Fundamentals. How are we going to compare the characters, each and everything? How are we going to reducing the complexity of the particular process? Okay, please focus on here slide. I'm going to show the fundamental. Fundamentals are nothing but, see here fundamentals. See, these are fundamentals. You can call it as a preliminaries. You can call. First one is what? Length of the text. You can check out the length of the text first. What is the length they have given? We should be check the string of the length. After that, what? They will give the pattern. We'll check that pattern, length of the pattern we're going to check. In the sense of input size of the pattern we're going to check. Input size of the pattern we're going to check. Next is what? Size of the alphabet. What is the size of the alphabet he has given? We want to find out. After that is what? We accept the number of comparison. We're going to comparing the each characters. Each character we're going to compare. Comparing time only we're going to get matching or not matching. We're going to determine the pattern. Within the pattern we're going to find or not. We're going to check. Then we're moving to next slide. See here, Bimore. Why is Bimore came? Bimore algorithm came. Already several algorithms are there. Why? What is the need of the Bimore algorithm? What do you want to do here? See, then the name indicating that Boyer-More. Two persons are there. Boyer-More. Two persons developed this one. When they developed 1977, they developed this algorithm. Why they developed this one? See, full name of the Boyer-More means R.S. Boyer-More. Again, More, J.S. More. You can call two members developed at 1977. They developed this algorithm. Why they developed? Already several algorithms are there. Why means what? They're comparing the each algorithm. Brute post one algorithm is there. That brute post taking, that's all the same process is there. Comparing the characters, it's going to be checked, it's going to find out in the pattern. But it will take consuming the more memory and more pace. That's why that both persons are going to be develop on new algorithm. That is called Bimore algorithm. Why they develop? They want to make efficient. efficient algorithm want to make to search the particular characters in the string. They want to search. That's what they brought. Complexity compared to that brute force algorithm and Bohr-Moore algorithm is there very different. It's efficient. That is not that much efficient. That is a difference. That's why they developed Bohr-Moore algorithm. Next slide. See here, Bohr-Moore searching algorithm. It works by comparing the character of each characters which has given in where string as a length. You can check that again. You can take the pattern. You can compare each end from right to left. We are going to comparing the pattern. Right to left we are going to scan. Left to right we are going to compare. Comparing time anything mismatch we are going to get means what? We want to make what? We want to make pre-processing. Pre-processing what comes means we're going to provide bad character table. Good suffix table we're going to provide two tables. That two tables going to what it going to do? First it's going to be aligning the pattern. Aligning after it's going to be search the particular pattern in the string. Searching after what? Is the match is found or not? It's going to be detecting. This is the agenda of here. Okay. Next slide is what? See here. Bohr-Moore algorithm match shifting. See, suppose first character I am going to search. First character I am going to search. For example, already I given that example only I am going to take here. For example, you saw here. Okay. See first character. I am taking first character A. Suppose think that in place of A I am going to make what? E. I want to make what? E. E I want to make. So see A and E is going to be a mismatch. At that time what? I am getting problem here. That's why I should be provide what? Two things I want to provide. What I am going to provide? Bad character table and suffix, good suffix character we are going to provide here. Two tables we are going to provide. We want to solve this problem. Okay. I want to shift from here to here means what? We need the bad character table focus on bad character table to can take it, you can solve the problem which is the mismatching character will come. For example, I have given, again see the next point. Suppose the complexity is very efficient. Searching only, substring we are going to searching here in this string only. Substring we are going to search here. Nothing is wrong. Complexity what? O of m plus n here. Okay, compared to brute force is a very efficient. Whenever we are going to check that pattern, we should be focused on bad character table. See here. We want to shifting, match shifting. See here. Character B, character A. U is there. We're shifting. Suppose the match matching means we're going shifting to the next position. This time we're going to shift. When it's going to be occur mismatch. When we're going to get the mismatch, we should be move the cursor to one position to other position. Then again you can check the next character. Going on, comparing the characters only here. Okay. See here. Next up, same only. Occurrence shifting. What I said, occurrence shifting. Matching means you can move further. Not matching means you can focus on bad character table. Okay. See the next slide. See. For example, I shown you. Already I shown you. Again I am showing here example. See, he has given text. This is a text of the length. This is a pattern length. The both pattern length I am going to comparing and I am going to computing the shift here. I am going to comparing. So mismatch means we are going to focus on bad character table. Okay, na? Bad character you can focus. You can check out the particular character is there or not. You can check it. Is not there means what you are going to be star. Star going to be indicate what? Is unknown value we are going to take there as a star. Yes. Again, what I'm saying, see, match is matching. See, what I'm doing, we should be scan from right to left. That things only I'm doing. See, right means what? From here to here we want to scan. Left means what? Here to here can. Whenever I'm going to scan from right to left, we should be keep string and pattern. Both should be match. Match means what? Go to further position. Again, check the Z and R you are going to check. Again, you can check, see, mismatch is getting. I'm getting the mismatch here. Again, you can backward approach you can apply. Backward approach you can apply, you can focus on bad character table. Why are you using the bad character table means what? We're going to, how far we're going to shifting the particular pattern. How far we're going shifting. That is things we're using. See the next slide. See there. I'm telling two things that are two statistic or there. Okay, means I'm going to call it as a approach. What I'm going to call? I'm going to call two approaches. One approach is what? Bare character heuristics. Second is the good suffix heuristics. You can call two things, sir. Why are you using these two? These two only making us to solve the problem. Where is the mismatch we're getting? We're going to solve that problem. Means what? We're using the two bad character and good suffix. We're using these two are very important. We're going to how far we're going to shift a particular pattern. It is going to be determining here. Okay, see there what is creating the array. Okay, to store the rightmost occurrence of the each characters. What I said, first you can scan from right to left. Checking each character, comparison, you can compare each character, you can check it. If mismatch comes on, focus on bad character table. Bad character table. Further an example, I will explain that one. And now come to good suffix heuristics. Good suffix heuristics means when we will getting the matching the character. When we get matching the character, we can save that particular space. We can move to the further position. Okay, na? Next is what? See this one. For example, see he has given pattern, he has given string, he has given pattern. The both going to be comparing. Compare from what? From right to left, we are going to comparing here characters. See first character B is there. Text also B is there. Pattern also B is there. Both matching. Both matching means what? You can forward one position to ahead. Again you can check the compare the characters. Again we are comparing character of position 1 and position 1. AC is there. AC means what? Mismatching. Mismatching, see he indicating the diagram cross. He indicating diagram was this is a bad character. We can call this is a bad character. When we are getting the bad character, we focus on bad character table 2 can how far we are going to shift in the particular pattern. How far, how much it will, what is the value. When we are going to create that particular bad character table, I want to show that one. Okay? Now next is see the next is see the next I am going to moving. See first here again I shifted this one to here. See shifted see first position always you can skip. Move to next position. Again you can compare A B. Again mismatching. It is indicating that bad character. See the in the slide is mentioning that bad character he mentioned. Again you can move further position. Move and you can check compare scanning from right to left you can scan. Again you can check it. See again in next lot is comparing. See again you come to here again comparing B matching, C matching, A matching. This is a matching. When focusing on bad character table, we come to know how to solve this problem. Next word you can see it. See 2-3 lines here. See again already I showed this is a pre-process. I told pre-process means what? Creating the bad character table and good suffix character we're going to create. Creating that somehow what is the problem mismatching coming? We're going to focus on bad character table. We're going to solve the problem. See next is what? Align the pattern with the beginning of the text. Aligning the particular string and pattern. Okay. Next is what? Compare the pattern with the text. We're comparing each pattern and the text we're going to comparing. Okay. Again is if all the character pattern matches, valid occurrence is found. Means what? See string is there, pattern is there. If a matching means see this is a matching. We found which position? 0, 1, 2, 3. Third position I matched my pattern. You can say this is a concept. Okay, next slide you can see that good suffix. Bad suffix character we saw. How far we are going to shifting the pattern. Now it is a good suffix. Good suffix shifting 1 means what? We want to shift. How we are going to shift that one means what? We want to check first in string and pattern. Where is a string and pattern going to be matched, that you can take count. When mismatch comes means what? You want to focus on bad character table. Here you see the, for example, good suffix given, string A has given, pattern A has given. E checking started from right to left is scanning. Scanning in the sense what? String and pattern is going to check. See, right, from right side we're going to scan. Scanning time what? TT matching. E wrote green. Again GG matching. Okay, matching. E wrote what? Green only. Within that whatever they indicating the green color, that is matching. Which is the indicating there's a cross marks, that is not matching. See there next is the C A is there. This character is not matching. This is called mismatch you can call. Okay, whatever things I got match, you can make it a green. This is a you can call good suffix. Okay, now further you can say here also you can matching, here we are not matching, here matching, we are not again you are matching. In this you can take, see GT is there. Which is matching you can take. There is a good suffix shift you can call. Okay, next diagram you can see here also you can shifted. Again you came here, you comparing TT matching, again T is a TZ is not matching. Moving on only, wherever matching is going to mention is not matching means what? Is checking the particular things. Okay, see next slide, you can check it. See, this is a Boehmer algorithm. Algorithm is given. I want to process. First, what is my agenda is what? I want to take input size of the length. String you can take. Next is what? The pattern length. Next is what? We want to take is what? Alphabet size. After that, we want to search. These things only given. See, Boehmer matching. He taken what? Text. He is taken a pattern. He is taken patching. Again, length of that particular string. Again, pattern. Again, what? Computing. Computing in the sense I want to calculate that one. I want to start comparing each character in the text using the pattern. We want to compare each characters. When a character going to be matched means what? It will come to while. It's going to be frequently. It's going to be moving on only. While comes it moving only. Moving, repeating only. Iteration going to be moving only. When it mismatch comes, it's going to focus on the bad character table. It's going to be move bad character table. Okay, then it's going to be print as pattern occurs. Occurs means what? We got the pattern matching. We found matching. We found means it's going to be show this one. Not matching means it's moving on only. While loop is moving on the iteration. Not matching means what? It will come out of the loop. Next is what? For example, already I given this example. I given. Here I want to display video. Okay, you come to know how is the working process of that particular video. See, whenever example is there, want to see this is a video. What it going to be say? It's going to be tell how it working process is there. What is the working process is there? Okay, na? Here see is we want to create one bad character table here. Okay, na? Bad character table. Based on bad character table, we're going to use one second. I want to tell the first formula of that particular, how we're going to calculate the particular values. The pattern value I want to calculate means what? See there, I want to tell first the value, how we're going to calculate the particular value to can find out the character which is occur, not for mismatching occur. That thing we're going to see here. Check here. Check. See here. See here once again. See, I want to write the formula is what? Value equal to. Okay, na? Value equal to. What is the length of that particular string? That one you can write here. Length of string we can take. Length of string minus index. What is the index he has given? That you can take. Index. Again minus 1. This formula you can apply. Okay, na? Whatever the he has given length, you can write down. Suppose for example, 7 you given. Take it. Again, which index? Start 0th index you can take. Again, you can take minus 1. Can you make it? You can find out the value. This like you're going to find out the value of the bad character. That bad character you can stay. For example, we want to check is what? See, for example, star mark. What star mark going to be indicate means what? Unknown character. See, for example, I have letter. Okay, na? Letter I have. Okay, na? Letter I have. But what will happen? Out of this letter, I got any letter. Instead of I got M I got. Mismatching M means what? I want to check the letter. See, out of letter, this LETTER, M is not there. This is called mismatching here. Mismatching in the sense not there in the letter. The bad character indicates that star. Star means unknown. Instead of this letter, you can take this star as a value. You can take star as value. 1, 2, 3, 4, 5, 6. 6 is there, you can take 6. This is the value of star. This indicating here in bad character table. This formula is there. In that video, they given formula 1 dot. 1 into length. Into means what? It will come same value only. Okay, that's why I'm using length minus index minus 1. Okay, na? You can find out the bad character values. Okay, na? See here, I want to show you how it will work. I will show you. Just check it. Video once you will check means you will come to know how it is going to be working. What is the process of working? That one you come to know. Okay, na? See here, video. Okay, for that I showed you concept of this one. See here in the video I am showing. See there, what nothing is there. They are giving the pattern, length of the pattern they are given. Again, the string of the length they are also given. We want to compare that one here. Where we can first we can create what bad table character we want to create here. See here, video input they will give. I'm saying now length of the string they will give. Again, length of the pattern they are going to give. Both they are going to give. After that, what we want to create pre-processing that particular value means what we want to create the bad character table. We can create the bad character table here. Want to create means what? First you can take what is the length 1, 2, 3, 4. 4 are there. 4 characters. You insert here 4 characters. You find out as per the according to I said the formula. I said the formula here. See here formula. See here formula. You can use the formula. You can find out the bad character values. See, I have given value equal to length minus index minus 1 I have given. Now this you can use it. You can use it in this one. You can you can find out the value of that bad character table value. You can find out. Based on that bad character, we are going to focus on where is the mismatch comes. You can focus on bad character table only. Then we are going to solve that particular whichever come problem. We are going to solve that one. Okay, now see the video. Where nothing is there, a string they'll give. We're going to focus on length of the string. We're going to focus on pattern of that particular string. We're going to focus. Then we're going to start searching, comparing the each character in this whichever given the search text they'll give. You can search in that pattern. Okay, pattern is matching means what? No need to focus on bad character table. No need to focus. Mismatch comes means only you can focus on bad character table. See here, bad character table we're going to create using this pattern. Using this pattern, we're going to find out the value. That formula, what formula I given, that formula use it, you can find out the value where. Okay, value will get the value. That value we're going to start comparing each. Okay, this starting from 0th index, starting from 0th index, you start from right to left scanning. Okay, but 0th index, first index, second index, third index. This like we're going to count, but we can scan from right to left. Okay, see, this is the formula we're going to use. We get the value here. Here t, what is the value? Use the formula, find out, you can place here. You can use the formula, then you can find out the value, you can insert here. Use the formula, you can find out the value, insert here. Okay, then you can moving on, scanning from right to left, you can scan, you should be check each character. Mismatching means what? Focus on bad character table, you can focus. But not mismatch means what? Moving only. Moving and checking. First you can check this character, okay, second you can check this one, third you can check. For example, you will get the mismatch means what? Stop here. Focus on bad character table. Go to that one. You can check it. Okay, na? See over there. Same thing. We're going to find out in the value here. Bad character value we're going to find out. It will come using the formula what I wrote there. That formula use it. You can find out the value place here. Placing after you can compare. Comparing that. So our mismatch comes here means what? You should not consider this first character. First index should not be character. You should not consider. You skip this one. Start counting from here. Start count. What value will get here? That value you can take it. You can count. After counting, shift this pattern to here. Okay, shift pattern to here. Where it will come? You shift here. Again, start comparing. Same process going to be take place. Pre-processing going to be take place. Okay, this both bad character table and good suffix table. Okay, use both. We're going to solve that problem. Correct? See here, they find out using the formula. I wrote this formula, same formula, you can use it. Find out the value. We're going to place the value. We're comparing only, ongoing comparing. Where you will get the pattern matching, you stop. Pattern not matching means moving only. Where pattern is matching, that particular pattern got, which index you getting, that index you can, my pattern is found, you can write in, you can stop the process. See there, you got 3. This value you can insert this like. Okay, same thing you can find out this one, same thing you can find out, insert, start comparing each characters. Then only you will get the string. Within the string, we're going to find out in the pattern. What is the agenda is out? We're going to determine the pattern within the main string or text. We're going to find out these things only. We're doing here. See calculation again 2 kms. Use the formula, insert. Again we're going to calculate this one. Yes. How you can use the length? How much length is there? You can take. Again you can take the length of this index. You can take it again, make it minus. That formula can apply. Again you will get the value. Insert here. Okay, this is the process of By-Morey algorithm. Okay, if suppose sometimes suffix, good suffix character is the something matches it comes, but no problem, nothing will happen. We can take, we can only modify that one. Modify in the sense what we can highlight that one. Green, you can highlight it. You can move to the same character is there, or you can check it. Check, then you can mention that character, where is that position. You can mention it. Okay, same thing here. See, I got the S value. Using this formula, I got the S value. This, like, you can see the in this text, S is there. Okay, S value is 1. You can easily find out. You can move to H. Check it, H. H is not there. Then you can consider as H value is star. Star. H value is what? Star. You can take. What is the H value now? 1, 2, 3, 4. 4 is a star value. That we are going to consider because of H. H is not reflecting in the pattern. You can go to consider as star as that value. Okay, na? You can take value. What is the star? 4. 4 means 1, 2, 3, 4. 4 you can take. This is the value. Moving on, only concept we are going to take. Okay, na? Only comparing and shifting, from, you can scanning from right to left, counting from left to right. This is only rules here. Scanning from right to left, counting from left to right. You can count here. When when we're going to mismatch comes, you can focus on. See, I told 4. Star is 4. This, like, you can, because out of this any character comes, means you can take value as 4 only. Star value you can take. That's why star is playing important role here. Okay? See, this is a concept of By-Morey algorithm. The concept I explained in detail about the By-Morey algorithm. Time complexity of By-Morey algorithm, O of m plus n. Thank you one and all for listening.